Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are doing part two of our spiral review for Algebra 2. This is, I believe, chapter 8. We are looking at series and sequences in this chapter. So these are 5 questions that a student sent in so that he was doing a spiral review and he said, hey, I need some help with these 5 questions. So we're just going to get right to it. Okay. So in this particular chapter, I believe it's chapter 8 of the Big Ideas textbook. We are looking at series and sequences, and there are a lot of formulas to remember. So if you can start to memorize them, that would be great. But I really believe that the best way to memorize the formulas in any math class in general is to just do problem after problem after problem so that you can just have that muscle memory of the work, right? Of the way to solve the problem. So in this particular case, we are asked to write a rule for the sequence. Now, there are 2 kinds of sequences. There's an algebraic, arithmetic, and geometric. The arithmetic one is just one where you are consistently adding the same thing over and over and over again. And the geometric one is one where you are constantly multiplying over and over and over again the same exact number. So we really want to figure out first, is this arithmetic or geometric? So one way to do that is you can tell whether you're adding or subtracting is by like, hey, I know I'm going to go ahead and add 6 here. So then I actually am going to add 6 here and I'm going to add 6 here. This worked out really nicely. I just chose arithmetic first. I figured out that I'm adding 6, and then I see that I'm adding 6 over and over and over again. Therefore, it's an arithmetic sequence, which means I'm going to use the formula plus n minus 1d. I have seen it written like this also, where the d is first, but I think in the book they do the d at the end, and I'm not sure why. They're just being silly. Okay. So a sub 1 means that this is the first term. A sub n means we're looking for the nth term, right? And so when we're writing a rule for this sequence, we kind of want to find a rule for the nth term. And the nth term just means it's like after all of these other numbers, what is going to happen at letter n? This n will stay n when we're writing a rule. And this d stands for the difference, the common difference. And in this case, my common difference is 6. Okay, this is my first term. My common difference is 6. And we don't know where n is, so n will stay as is. So what I'm going to do is first, I'm going to go a sub n is going to be my first term 8 plus my common difference of 6 n times n minus 1. I'm going to distribute this 6. I'm going to end up with 8 plus 6n minus 6. And then I can combine like terms. So I'm going to get a sub n is 6n plus 2. And that's it. That's my final answer. This is the rule for my sequence. Sometimes you might notice that this is kind of like a linear equation format, a y equals mx plus b, if you will. You can go in and graph it. You don't have to, but you can. Sometimes they will ask you to graph it as well. Okay, in the geometric sequence, so now this is geometric. So now we know we're going to multiply the same thing over and over and over again, okay? In the geometric sequence where a sub 3 is 2/3 and a sub 6 is 144, find a sub 5. Now, there are some instances where you can just kind of like find the middle and the middle and the middle in order to get what you need. But in this case, there's not really a middle. And I also think I did not leave enough room for myself. So I'm going to do my very best to see what we can do here. So just so we're on the same page, and I'm gonna kind of isolate this like that, I think. Yeah. Okay. So we've got a sub 3 is 2/3. Then we're going to end up with a sub 4. Then we're going to end up with a sub 5. And then we've got a sub 6 is 144. So there's not really a middle number between 3 and 6 because we've got 2. If we were looking for the 5th term, we would be kind of like, hey, let's find the average of these two, and then we'll add the same or multiply the same thing on both sides. but it won't work in this case. In this particular case, our job is to do a system of equations, which if you're an Algebra 2 student, you've definitely done systems of equations earlier in Algebra 2, probably in chapter 1 or 2. You've definitely done systems of equations in Algebra 1 and in pre-algebra as well. So this is definitely the fourth time you're seeing systems of equations. You may not remember what they're called, but you've definitely seen them before. So let me refresh your memory. Our goal is to get two different equations with two variables that we don't know in order for us to be able to find both variables. So in an arithmetic sequence, this is what our equation looks like. In a geometric sequence, this is what our equation looks like. Because a sub n is a sub 1 times r to the n power. So this is the rate. So when I look at this, I'm going to go, okay, I know a sub 3 is a sub 1, which is, I don't know what that one is, which is the rate, which I also don't know what that is to the n power. I can actually replace the n with 3 because I know that n has a 3 here. And I can also replace a sub 3 with 2/3 because that is the value of a sub 3. Okay. The other term is a sub 6 and 144. So for that one, I can say, hey, 144 is a sub 1 times the rate to the 6th power. One thing that you're going to notice is your a is the same in both cases. So I'm going to get a on its own for both of them. So a is actually 2/3 divided by r cubed. And a is also 144 divided by r to the 6th. All I'm doing is dividing on both sides by the same thing to cross this out and cross this out. Okay, beautiful. I can then go in and change this up a little bit. So when I divide with fractions, I'm going to multiply by the reciprocal. So in order to move this up, I'm going to multiply by 1 over r to the 3rd. So really, a is equal to 2 over 3r to the 3rd. I can then set these two equal to each other. So 2 over r3 to the 3rd, 2 over 3r to the 3rd is equal to 144 over r to the 6th. And I know that I can simplify across with fractions. If you don't know that, you can. I know that if I have 3 r's here, I can take away 3 r's from here and here and just be left with r to the 3rd. If that doesn't make you feel comfortable, just go ahead and multiply, like cross multiply, and you'll see eventually you're going to cancel them out. I also know that I can simplify here, divide by 2, and end up with 72. So realistically, I'm going to have r to the 3rd equals 216. I'm then going to find the cube root of both r to the 3rd, which is going to be r, the cube root of 216, which is 6. And now I found my rate. In this particular case, I can do one of two things. I can multiply this times 6 to get the 4th term, right? And that will be what, 12 over 3. I can simplify this and get 6. Yeah, 6. Okay. And then I can multiply this by 6 and get 36. And then just to double check, I can multiply that by 6. And it just so happens to be that, why do those numbers look a little fishy? 2/3 times 6 is 4, not 6. That's why things look fishy. Okay. Okay, so I am multiplying by 6. Here we go, 6. And I'm getting, this is 4, and then I'm multiplying that by 6 to get the fifth term is 24. And when I multiply that by 6, yes, it is in fact the sixth term, which is 144. Okay, beautiful. So my fifth term is 24. Okay, if you are given a calculator, I think this problem does not require a calculator at all. I think I just had a little bit of a brain fart because I've been doing too many math videos today. Um, but if this is not a non-calculator test, it's absolutely doable. You just have to be careful with your multiplication and division. Other than that, this is my final answer. The fifth term is 24. Okay, find the sixth term of the geometric sequence. Again, we're multiplying over and over again, where the first term is 2 and the common ratio is negative x. So I know that a sub n is equal to the first term times the rate to the n power. When I have the rate to the n power, so I know that my common ratio is negative x, so I'm going to replace r with a negative x. I know that the first term they're telling me is 2, so I'm going to multiply by 2. And I know that I'm looking for the sixth term, so I'm going to go a sub 6. And because my n's repeat in 2 places, I'm going to put this as 6 here as well. So now I can say that my sixth term is 2x to the 6th. And I can say that only because I know that if I have 6 negative numbers, I know that it's going to become a positive. So I would say this is probably the most simplified version. If your teacher accepts this, I would probably not. I would want it more simplified in this fashion. I think I have seen some teachers accept this type of answer as well. Okay, so now we're looking for the sum of these numbers. And in this particular case, because I know this is linear, I know I'm going to consistently add the same thing or subtract the same thing every single time. I know that this 25 means I have 25 terms. And I also know that this 1, I equals 1, means that my first term starts where I is 1. So I'm going to replace this I right here with 1 to find my first term. I also know that my sum of all of these numbers is going to be n times a sub 1 plus a sub n divided by 2. So the sum of 25 numbers is going to be 25 times the first term. Let's figure that one out. So I'm going to go 5 times 1 minus 2, which is this 5 minus 2, which is 3. And a sub n would be a sub 25. So it would be 5 times 25 minus 2. That's 125 minus 2 is 123. So, oops, not 2. 3 plus 123. And then all of that is going to get divided by 2. So I'm going to go 3 times 1, nope, not times, plus 3 plus 123 is 126 times 25 is that big number there, 3,150 divided by 2 is 1,575. And then that would be my final sum. Okay, a ball is dropped from a height of 40 meters. So let's say this is 0 meters, this is 40 meters. So a ball is dropped. And if it rebounds 3/4 of its height on each bounce. So it's like, here's the bottom floor, right? It goes down and then it bounces, but only 3/4, and then again, only 3/4, and then again, only 3/4. And eventually it'll like go up, 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 and like be flat, right? We know that part, but we really want to, understand what's happening here. Okay. It's asking what is the total distance of the up and down. So like we want this, right? All of that. Traveled by the time it comes to rest. So we are likely looking at, this is a sub 1. This is my rate. and we want it to equal 0 is what I'm thinking. So a sub n equals a sub 1 times the rate times n. So the rate is 3/4. We know that the first term is 40. And we don't know 3/4 of its height. We don't know what the n is, but we want this to equal 0 or as close to 0 as possible. Okay, so let's take a look at this a little bit. Seems like we want the total distance. Oh, total distance is sum. Okay, that's not supposed to be an 8, that's supposed to be an S. In order to find the sum of what seems to be probably an infinite series, because we eventually want it to just equal 0, is not quite this format here. We want the sum. So we don't want the series, we want the sum. So that's going to be 1 over, nope. I want to say it's the first term. Let me double check. Yes, it's the first term over 1 minus 3. So I know that my first term is going to be 40 meters, and I know that my rate is 3/4. So when we're looking at the sum, I've got 40 divided by, I guess, 1/4, right? Because 1 minus 3/4 is 1/4, and then we're looking at 160. When I take this and I notice that I am doing 160 is just like either the down or the up, I need to do both down and up. So I need to actually double that distance. So that really my sum of all of that is going to be 160 times 2, which is 2, nope, which is, why can't I think of math? 320 right now. Minus the original 40 because we don't need to go up and then down. We're just going down straight away, which is 280. So really the ball has traveled 280 meters. This is an interesting one. I can't imagine something like this would be on a test without having done at least 1 or 2 problems in class similar to this. So maybe if the ball is dropped from a height of 100 meters and it rebounds, half of its height or 2/3 of its height on each bounce, using the same kind of base problem with different numbers, I think would be super helpful. But essentially, you need to understand that you're finding the sum, and the sum is going up and down, except for the very first up. We're not doing that up. Like that's not happening. We're going from here down, and then it's not just going to be down, down, down every time. We have to go up, up, up also, which is why I'm multiplying this by 2. And then I'm taking away that original 40 because I don't have to go from 0 all the way up. Anyway, I hope that this was helpful, and I will see you in a later video. Bye.